Section 3.6, the chain rule. Sometime, we might have to find out the derivative of complicated looking kind of function. In that case, we can make it, we can simplify that before finding the derivative by changing that particular function into the composition of more than one function. So, for example, here, in this case, if f of u is a differentiable function, that means you can find out the derivative of this function at the point u, where u also has different value. U has a value, the u is itself is a function of x, and also where g of x is it's possible to find the derivative. This is differentiable. Then their composition, the derivative of their composition is actually the derivative of the first function f times the derivative of the second function g of x. I'm going to say very same thing indifferently. Let's say you have let's say y is function of u, but basically u is also u is a function of another variable x, and we're interested to find the derivative of y with respect to x. So at the beginning, as you can see, that y is a function of u, but u is a function of x, and we want to find out the rate of change of this function with respect to variable x. We can do that by finding the derivative of y with respect to u first, times it by the derivative of u with respect to x. So this is the chain of the derivative. Okay, that's why it's called chain rule. And we're going to see a couple of examples here. But before that, let's say you have exponential function e to the power u, and where u is a function of x, then to find out the derivative of e to the power u with respect to x is derivative of e to the power u with respect to u times the derivative of u with respect to x. Exactly the same thing I'm applying here for e to the power exponential function. We're going to use them in our examples. So look at here. First of all, we have given a function y equals 7x minus 16 to the power 8, and write the function below in the form y equal function of u, u equal function of x, and find the derivative. As you can see here, this is the composition of two different functions. We just have to split them. So what we can do is we can write down u equal the whatever value you have here inside the parentheses, 7x minus 16. By doing that, we can say y is u to the power 8. Look at here, y is u to the power 8, and u is 7x minus 16. So y is function of u. So look at here, y is function of u, y is just in term of u, and u is function of x. So now by using our formula here, if we want to find out the derivative of y with respect to x, we need to find out the derivative of y with respect to u times it by derivative of u with respect to x. So if your y is u to the power 8, what is the derivative of y with respect to u? Not x, with respect to u. To find out the derivative here, we can use the power rule, and by using power rule, it will be 8 times u to the power 7. What is the derivative of u with respect to x? This is just 7. Now we are going to use these two values, this one and this one here. So it would be 8 times u to the power 7 times 7. Eventually, look at here, we want to find out the rate of change of y with respect to x. Your answer is in term of u. We don't want to keep the answer in term of u, because u also depends on x. So eventually express your answer in term of x. So 8 times 7 is 56. Plug the value of u, which is 7x minus 16 to the power 7. So this is the final answer. Let's look at another problem. As it is, look at here, this it looks very complicated, but actually this is not complicated. For finding the derivative, we can always replace whatever comes inside the parentheses as a u. So u is x square over 4 plus 3x minus 2 over x, and you know u is that value, so y would be u to the power the whatever power you have here, which is 5. So by using the chain rule, the derivative of y with respect to x is the derivative of y with respect to u times derivative of u with respect to x. So what is the derivative of y with respect to u? It's a power rule, 5 times u to the power 4. That's the derivative. What is the derivative of u with respect to x? Again, power rule here. The derivative of x squared is 2x over 4 plus derivative of x is 1, so it's a 3, minus derivative of 1 over x is x to the power -1, so it would be eventually plus 2 over x squared. So we just use this two value here, dy over du, which is 5 times u to the power 4 times this one, which is if you simplify it, it would be x over 2 plus 2 over x squared plus 3. And you can plug the value of u, which is uh, finally we have to express our answer in terms of x, so we need to substitute the value of u back. So eventually this is our answer, y equal derivative of y with respect to x equal this one. Here we want to find out the derivative of y and then again second derivative. So as it is, you can see there is a y is x times this expression. This expression itself looks this is the power 5, so it's a product, so we need to use the product rule. So if you think about the product rule, if y is function of x times another function of x, then dy over dx can be found by finding the derivative of first function, leave the second function derivative, leave the first function and find the derivative of second function. So in this case we can assume that the second function here is g of x. To find the derivative of that, we can use the chain rule. So the first function, that's not a problem, it's just x, so derivative of that function is just 1. The second function g of x is it's a 2x plus 1 to the power 5. For finding the derivative of this function, we can treat this as u to the power 5. So derivative of this function is derivative of u to the power 5, derivative of u uh, to the power 5, which is function of u, so derivative of u to the power 5 with respect to u times derivative of u with respect to x. So derivative of u to the power 5 with respect to u is 5 times u to the power 4. This is the chain rule. And derivative of u with respect to x, as you can see that u is 2x plus 1, so derivative of u would be 2. So eventually it's a 10 times u to the power 4, but u to the power u means 2x plus 5. So this is the derivative, and it can be found by using the chain rule, the rule we're talking here. So now we can use f, f prime, g, and g prime for finding the derivative of y. So y prime is f prime, which is 1, times g, which is 2x plus 1 to the power 5, plus f, which is x, times g prime, which is 10 times 2x plus 1 to the power 5. So eventually it's a 2x plus 1 to the power 5. I can just factor it out and I can write down 1 plus 10x. So now look at here, y prime is again product of two different functions. So I can use the product rule again, and while finding the derivative of this part, I can see I can just use the chain rule one more time, because g of x, this is g of x and this is another function. Okay, so the derivative second time, if you want to find out the derivative second time, then derivative of this function, which we already found, that is 10 times 2x plus 1 to the power 5 times this function as it is, plus this function as it is, which is 2x plus 1 to the power 5 times the derivative of this function, which is the derivative of 1 is 0, derivative of 10x is 10. So I can just write it down 10. Okay. Okay, so if you want to simplify this more, then you can always do that. Just factor 10 and 2x plus 1 to the power 5. So let me do that. 10 2x plus 1 to the power 5, and write down the leftover thing inside this parenthesis, which is from first part it's a 1 plus 10x, plus second part it's just 1, so eventually 1 plus 10x plus 1, which is 2 plus 10x. Okay, and you can factor out 2 again, so let me go here. So 10 2x plus 1 to the power 5, 2 plus 10x. We can also factor out 2 from here, so 2 times 10 is 20, and then 2x plus 1 to the power 5 times 1 plus 5x. So that's the final answer. That's the second derivative. And now for finding the second derivative for the function like this, if you don't use the chain rule, it will be complicated. It takes time. Okay, so that's the chain rule.